people will be available, we can easily get resource. So whatever is popular among developer community is a good language that we should allow. And any application that I want to build in these modern days, I do not want someone to write everything from scratch. There should be some framework, already existing framework. So for example, we know there is a React framework if somebody wants to build a modern UI thing. There is Angular as well. So if these frameworks are not there, somebody need to write all the controls, the button, the ripple effect on the button, the click event handling, everything within the CSS, HTML, JavaScript from scratch. So that is the benefit of framework, because we don't have to do the repetitive things. We only have to focus on the core business logic that my customer or client needs. So this is one of the need. So we'll see how Java is backed by a framework as well. Mobile app development. Nowadays, only creating a web application or only creating a server-side application or something at enterprise level is not enough. Even those big companies who have their very famous ERPs out there in the market, millions of users are using it, like Microsoft Dynamics, Oracle, Fusion, Business Suite, SAP, and all those. They are also craving to build a mobile application which is nearly as good as their web counterpart. They want to give more and more controls, more and more features on the mobile or the tablet applications. So mobile app development is also something that is a need of modern software industry. And foremost, since many of the infrastructure has now moved to the cloud. Earlier, the cloud servers were not so popular, cloud computing was not so popular. Everybody wanted to have their in-house servers, they wanted to host the entire application on premise. So that time the microservices oriented architecture was not so popular, but these days we have Azure, we have Oracle cloud infrastructure, OCI, we have Amazon AWS. So all these technologies, they offer server, the compute instances on some cloud servers, so which are basically virtual machines. Sometimes they are dedicated servers as well. But on these servers, I cannot deploy a complete large application on one single server. So I have to basically divide my application into logically functioning parts, and each part we call it as microservice. So if I talk about an ERP has, let's say, 5 modules. Each module can be one microservice. If I further break it down, my module can have multiple features. Let's say HRMS module. It can have recruitment module, it can have assessment module, it can have payroll, it can have many other modules. So I can also break down my application into smaller microservices which are responsible for each of the module or the features within one module. So this actually raises a very good opinion about why not building microservices so that they are suitable for cloud. Because in cloud we want to make everything distributed and so geographically distributed that any user from across the globe can access my application with equal speed. So if I'm moving my application to, let's say, Amazon Cloud, then I would choose basically all the servers across the major portion of the globe, so that if somebody who is my customer and is part of, let's say, Asian region, they should be served from those servers which are close to the Asian region, or they have good connectivity or high speed from the Asian region. So if I'm hosting an ERP and I have sold my application to a customer who is in Asia, they should be able to access all the modules, let's say procurement module, finance module, invoicing module, inventory module, and all other modules from their region with quick speed. So that actually demands a software engineering team to break down their large application, we call them monolithic application, into microservices. So this is one of the foremost and newest need of the modern software industry, that this language or whichever technology we are using, it should be able to support creating microservices on the ease, which should be easily, I can convert any application using the same technology to microservice. If that is possible, then I don't have to train my entire team on something new. So let's see how Java actually supports all these things and becomes the best candidate out there in the market. So Java is robust, as I mentioned. It is now nearing 30 years of its making. They started in 1991, so that makes more than 30, though they launched it in 1996. And it's still a popular language, so it is really impressive. There are many languages which has seen upside down changes. Uh, Java is suitable for any deployment environment. As I mentioned earlier, we can deploy it on Windows, Mac or Linux servers. We can deploy them on Kubernetes, Docker containerized runtime environment, which is a very vital or a crucial thing in the cloud computing. It can also be deployed on IoT edge devices like Raspberry Pi. So if we want to build a smaller application which just collects something in a manufacturing plant or any industry where there is just need of a small computing device to collect some data and time to time send it to some API or some database. So we can implement or build a Java application, deploy it on a Raspberry Pi and put it somewhere in the manufacturing area, connect it to a Wi-Fi internet, and it can keep on sending us the data. So IoT and this cloud edge device computing is also crucial these days. Many solutions are not alone that you build a web application and a mobile application and the job is done. They also want to automate their entire flow or entire business and everything. So there are many things, activities going on. It all depends on industry to industry. So some industry rely heavily on IoT devices or the edge devices. Some industry do not need much, but still. And a very good example is our shopping malls where we have handheld devices. There are many shopping malls which provide us a small handheld device where we can simply roam around and scan QR codes or barcodes of the devices. And at the end, we can simply just pay when we submit that device. So these all IoT devices, they can offer many things, many functionalities, and Java has touched this area as well. Um, when it comes to mobile development, I would mostly mention about Android mobile development. Though I have not mentioned iOS and Mac desktop-based development, because Mac and iOS, they have kept their environment, I would say their ecosystem quite closed. So even if we talk about some cross environment technologies like Flutter or all these things, they eventually compile to their own native form of application. So if I'm building something on mobile device, if I'm using Java, I can easily build an Android application. But if I use a cross-platform, though I will be using some other language in the beginning, but eventually it is getting compiled to their own language, which is Swift for iOS, if I want to make mobile application. So I would not say that something out of the box offers something for iOS development, because they have kept it closed. But if somebody wants an application to be built on that, you have to have a Mac, because even if I do cross development on Windows machine for Mac, I have to actually switch to a Mac machine to test it. I have to switch to an iOS device, whether an iPad or iPhone, to test it or deploy it, even to debug it. So the nick is very closed for them. So I am not mentioning iOS mobile development done through Java as a straightaway, but you can do it. But eventually you have to do it on their environment using their own IDE, which is Xcode. So Java on Android mobile development is something which is very much compatible, because Android itself, the core of Android OS is based on Java. And Android mobile application that we build, this is the most closest native application for Android platform. They are the fastest, because if you write something on the native form, it is the fastest. So they get compiled and run fast on the Android application. One more point that I mentioned, which is the need of current industry's existence of any framework. And if anybody talks about Java and they don't mention Spring Boot, I think they are missing a big piece. Because Spring Boot has basically offered a lot of framework improvements over the past many years, and it has reduced a lot of boilerplate code for developers. Basically, before the introduction of Spring Boot, everybody thought that Java is a little tough when it comes to enterprise edition development. But with the introduction of Spring Framework or now Spring Boot, it has reduced a lot. Now I can create a basic, let's say, web API application within 10 minutes using Spring Boot. Spring Boot let us kickstart a full-fledged web MVC application, REST API backend based application, or a security auth application. So Spring Boot project offers many two editions since the day, not the day one, but in the 4th and 50th of their release. They actually segregated their core libraries into two parts. All the core language features, all the basic APIs, they put it under the Java Standard Edition. We also know it as Java SE. And there are some enterprise level APIs which they have put under the Java Enterprise Edition. The reason for this segregation is um, the full package was too big that many companies was thinking that this is only for the enterprise level software development. It is only for the bigger companies to use. And Java did not want to stay on that path where it is only loved by big companies, but small companies or small enterprises or any small application that I want to build, I would not think about Java. So they actually separated this into two editions. The second one, the enterprise edition, is used to build enterprise level scalable and distributed applications, whereas the standard edition is used to build application like desktop application or console application or some basic server applications. The standard edition contained the core library, the JavaFX, which is used to create the GUI, the JDBC, JVM, the input-output APIs, networking, all the data structure concepts. The GUI development can be done well in standard edition. But if you want to build something like that contains servlets, JSPs, Java message services, Java persistence API, which is the one of the foundations of Hibernate, if you know this framework, where someone who is just a backend developer or a programming developer and doesn't know about databases, they can create classes. The classes will automatically map to some of the tables in the database, and you just have to create the repository and all the implementations, and you don't have to even write a single SQL statement to insert something in the database or read something from the database. So this concept is called as ORM, Object Relationship Modeling, and JPA is one of the foundation stone for that. There is a parallel technology in .NET as well, if you have heard about it. It's called Entity Framework. But JPA was launched way before Entity Framework. So Java did that already earlier. Context dependency injection, which means I only create the interfaces in my application, and through the dependency injection I can basically inject those classes which implement those interfaces. So this is very useful if I want to write a program which is based on test driven development, which means I developed an application on interfaces. I would not know how the implementation is done, but my program can handle an interface very easily. So if I do test driven development, which means during the testing, when the integrated tests run, when I run my program, the implementations are replaced by test classes or mocked classes, and when the production is released, the interfaces are replaced by the actual implementation of the classes. So this way, test-driven development, domain-driven development, and all these things are supported through the context UI. We can use Enterprise Edition for web development, web services development, which could be in SOAP or REST, you might have heard. So there is no single approach or methodology that Java has not touched ever since its existence. So this is a complete package which gives us everything. Now, that was all about the history of Java, what Java is capable of, what Java has offered to its developers since its existence. Now I would like to talk about what are the needs of modern software industry and where does actually Java fits in that thing. So we need, every modern software industry need a robust language, and by robust language I mean to say the language should not have any ambiguity, the language should be precise and it should be stable. If its documentation says it works like this, it should always work like this on all the platforms. It should be well tested, and all the integration tests are done, backward compatibility tests are done before actually release it to the developer community, which Java does. So Java is indeed a robust language. It should support wide range of target platforms, which Java already does, because that was one of the initial caveat of Java, that it can run. You just have to write once, and it can run on any platform. Java should support scalable solutions. So since we had the Enterprise Edition Java EE, so we can build scalable solutions. The main key for scalability is you should be able to build distributed systems. If my system is just one single piece of software, one single file which contains all the logic, that is hard to scale. But if I make my software distributed, which means it is not only spanned over one server, I can deploy some of the components on one server, some components on other, so I can scale it. So for example, if I divide my software, there is a need of communication among themselves. Means one P should be able to talk to another. So for example, there is a large ERP solution that does the order processing and inventory management both. So if order processing system has processed the order has been received, then obviously the inventory should increment according to the order received. So if my software is distributed, which means there are 5 servers which are managing the load, expression chaining, processing of XML and XSLT, they all become part of Java already. Their versioning changed after 1.4. They, instead of mentioning or saying 1.5, they started saying Java 5 has been launched. So ever since then, this 1.x version notion is dropped, and they started mentioning the numbers as just these simple integers. Java 5 was launched with many things like generics. Whenever we learn a language, we always have to specify a type in some of the arguments. But generics is something where you can specify type as a dynamic thing. So you must have seen expression like method or say repository of type T, where T you can specify as string or anything. So this dynamic programming is something introduced in Java 5. Enumeration and many other features are added. There are many companies who started building serious products around Java 6. When Java 6 was introduced, very good support for web services, XML processing and JDBC, robust and reliable support for JDBC was added. And some serious products were made at the time of Java 6. And one of the company which was very pioneering in terms of database, Oracle at that time, they started building their one of the initial set of ERP applications. Though there were some applications that they have already created, but that application has seen a great improvement when Java 6 was introduced. So I'll talk about those applications towards the end of this slide as well, as a special mention. With the Java 7, few other features were introduced. Basically, one of the most talked about feature that I mentioned here is the diamond operator, where I can specify, for example, when you specify a list, basically a variable of type list, you can specify list contain which data type. So in angle brackets, which is called diamond operator, you can specify list of strings, list of say integers, list of any other object that you have created on. So this was introduced in Java 7. As we know, in many software or many operating system, there is a long-term support version. So we call it LTS. So I have highlighted Java 8 as the LTS, which means Sun System promised there will be security fixes, patches, updates to this edition for a longer duration than any other, so that developer can actually rely on one of the version and a software can stay on that version for a longer duration. Because if it keeps on changing, then it is an extra work for organization as well to keep up or upgrade the current version or current source code to match with a new release of Java. So many organizations start following this. You must have seen a famous Linux distribution which we know as Ubuntu. Every 3 years they release an LTS version, which means if you install that, it will get updates for a longer duration as compared to the other standard versions. So similarly, Java also launched first LTS edition, which is Java 8, and they added a very good thing, Lambda expression and data API. And Java 8 was quite popular till the time of next Java LTS version was not launched. So many industries, they kept their software running on Java 8, and the next LTS version which was released in Java, they switched directly to that one instead of switching to any other the intermediate ones. So it's a good strategy if you want to build something big. We do not want to keep on changing it just because the software update or basically the language or the technology has seen an update. If I talk about further addition, there is a slight change in terms of release. If you see, Java releases are not equally timed. Some are released the immediate next year, some are released after 2 or 3 years of gap. So they actually did not follow any pattern until they moved to Java 10. So in Java 10, they actually realized that we should be having a time-based release versioning. So why it become popular in big companies. So Trust me, in the industry and in the market, many of the applications that currently exist, nearly 60% of them are built in Java. I'm talking about really large application. So since Java came in around 28 years ago, many applications they were actually trying to find a language which they can rely on in terms of many things. So Java was the only possible candidate at that time, which was quite portable. So many companies grabbed this language quite early. They built their major application. Now it is nearly impossible for them to rewrite that entire thing in any other stack or any other technology, or they do not even want to, because Java is offering them everything. Java is getting updates. Java is including all the security patches and everything every now and then. So they are not even interested moving away from Java. So one of the major factors they like Java is the security implementation which Java has on. One more thing that I would like to mention, I got this question from one of my new team members who is just a fresher. They asked that why should we not use Node and all these newer technologies on the server side as well, because Node also has good capability. My answer to that is only one. If you are building a software and you are hosting it in your own premise, and you are only offering software as a service to your customer, you are not hosting it on their servers or in their cloud or anywhere else. Because in Node, everything is JavaScript. So server side things or all the implementation you do in JavaScript. And that is the plain code. Means anybody can look at it and deduce how you have done the things. What is the core or the crux of your application, how you implemented that thing, how you cracked that logic, everything is out there. So if I want to build something that is not compilable, Node is not compiled, it is just run through a JavaScript runtime. So if it is not compiled, which means if I have to ship my software to such a client who says that implement it on my server, which means I have given entire intelligence in that piece of code to my customer. If for some reason they want to research it and maybe rewrite it or maybe just own it, I will not be having any control. They will no longer be relying on me to gain more updates about the application. They can take control because they have entire source code. And source code is basically your proprietary information. You do not want to pass it on simply. If Microsoft has made it operating system open source from the day one, I have rewritten the entire Microsoft OS, just like the Linux operating system does. But there are some things that I want to emphasize, that if you are building something commercially, it is good if you are keeping your source code with you. So that is not possible in Node application. So if you have to deploy if you want to free to deploy anywhere, then do not choose anything which exposes your code. Always deploy something which compiles into something which is not reverse compilable. Alright, so another another thing why enterprise prefer Java is very simple and very powerful. So we are able to create many things which are very reusable. Developer can create new application faster by modifying the existing ones. So it is not Java is not very complex. It's pretty simple. The syntax is pretty simple. The new things that are added they are added with proper documentation, and they are not very confusing. Such as I mentioned, Java is core of Android OS, so it actually adds a big value add for the big companies, and they also prefer that if they want to make mobile application, which is equally important in their current application, which is web based, they seek Java developers more. So Java developer would be always needed. Somebody wants to build mobile application. Beside software development, widely used in modern technologies like AI, big data, and IoT and blockchain as well. So it is not like that I cannot do all of these in Java. We can do it. And companies that use Java are Google, LinkedIn, PayPal, Netflix, Airbnb, Google introduced Android, and Android is based on Java, as we know. eBay